All right, so today we're going to be making an orthonormal basis. The goal is going to be, given any basis, we want to turn it into an orthonormal basis. So just as a reminder, this ortho means it has to be pairwise perpendicular. So it has to form a nice rectangular grid. And this normal means the lengths of the vectors has to be 1. So not only does it have to be rectangular, it has to be square. And so we might have a basis for R2 that forms a grid that looks like this. And of course, we know that we can make a nice rectangular and square grid with an orthonormal basis with the standard basis. There's always going to be an orthonormal basis for any subspace, but in this case, we know definitely there's one for R2. And what we want to be able to do is take the basis and change it so it's something that's orthonormal. What we're going to do is we're going to do this by picture first because there's going to be a formula, but that formula is going to be very complicated. In fact, I would suggest that the formula is not easy to memorize, but if you understand what the process is, you'll memorize the formula without actually realizing it. So in order to turn this into an orthonormal basis, we need to do two things. We have to make them perpendicular and make the lengths 1. So what we're going to do is we're going to pick one vector, and we're going to do both of those things. Now, for the first vector, there's no previous vector. So for the first vector, which we'll just choose the red one, we're just going to shorten it. Or lengthen it up so that its length is 1. So the first step we're going to do is we're going to take that red vector, and now we're going to just shorten it so its length is 1. And now we're going to discard the old version. So we're just going to make the length 1. And now that meets the first one, and it also kind of meets the second one, because what we're going to do is we're going to make every subsequent vector perpendicular to all the previous ones. So we're kind of done with the red one. So the first vector, all you have to do is shorten it up or lengthen it up so its norm is 1. Now for the next vector, what do we need to do? Well, we need to shorten it up and make the length 1. Now I'm doing this, the first one, we kind of shortened it up first because there wasn't any need to make it perpendicular to previous vectors. But what we want to do first for the next one is make it perpendicular. And we do this by projecting away and keeping the orthogonal part. You can think of this way as throwing away the shadows. The first step you're going to do for every vector is you're going to throw away the shadow onto the previous vector. So for example, this green vector right here, if we project it onto the line generated by that first vector, then we have this projection right here. We have this projection right here. We're going to toss that away. So what we're going to do is we're then just going to keep this next, we're going to keep that part right there. We're going to throw away the projection. And we're going to keep this part right here. So altogether, what does our basis look like now? We have that red vector, that shortened red vector, that was the first one. And we also have this green vector. The green vector is now orthogonal, but it's not necessarily length 1. So the next thing we need to do, the two steps we need to do, is we need to make this shorten or lengthen the result to norm 1. So we're going to go ahead and shorten that guy up. Here we can just do that. And now we have this nice rectangular square grid. And this square grid still has the same span as the original one. It still spans all of R2. So this original one spanned all of R2 in a weird way. And this other grid is going to create a grid that spans all of R2, but now does it in a much more simplistic way because it's a square grid. All right, so this is how we can take some basis up here. We can take some basis like that looks like this, and we can convert it into a square grid whose basis now has just these two vectors that spans the same exact space, that spans the same exact object. So let's go ahead and try to take these ideas and put them into a formula. So what's the formula that we want to do? We're going to do the same steps, but now we're going to put it in the language of algebra and make it into a formula. So kind of step one for the first vector, let's first go back and say, what are we given? We're given a bunch of basis vectors. This is a basis. And we want, right, we want V1 and V2 and V3, a new basis that's orthonormal. All right, so what we're going to do, the first step was to just shorten it up. The first step right here was just to shorten up the first vector. So we're going to take that B1, and that first thing is what we're going to do is we're going to shorten it up. To make it norm 1, we just divide by the actual norm, and that's going to give us the end result that we want for the first vector. So this right here just gives us the first vector, and sure enough, that's what we did upstairs. So all we did to get the first norm 1 vector was just to shorten up the first vector we chose. It's important to understand that the order that you do these in is going to result in a different answer. The answer isn't wrong. You're going to get a different grid that spans the same space. But in any case, it's still going to be orthonormal, but just be mindful that if you compare your answer and your basis at the end with someone else's, it may be different, but that doesn't mean you followed the wrong procedure. But the order is going to change your answer. All right, so this is how we get V1. And then what do we do for the next one? For the next one, what do we get for V2? Well, the first thing that we did was we subtracted out the projection. So what we're going to do is we're now going to take this second one and we're going to subtract out the projection of it onto the previous one. And then we divided by the norm of this. So if this was step 1, and then the dividing out was step 2. So perhaps a more general formula to kind of make this more concrete, if we kept going, what would we do? Well, what we would do is we would say, okay, we're going to take V1 to be B1 over the norm. And then we're going to introduce an intermediary vector. We're going to call this W2. So W2 is going to be this step 1. This is the step 1 part that we're going to do. We're going to take our original basis for 2, and we're going to subtract out the projection for V1. And then we're going to finalize it by just saying, okay, the vector we want, this is the one that we want. It's just going to be what we got from above divided by the norm of that. And now what's really nice is this kind of keeps going. So if we want to keep going, okay, what does the third vector do? Well, for the third vector, what we need to do is we have to take the original third vector. And now one of the main differences is now there's 2 vectors to project out on. And now this is where the orthonormal basis really shines, because when we did the orthonormal basis, we made a big point about how if you project onto a subspace, you can't just project onto the individual vectors unless they're an orthonormal basis. So these are already orthonormal. So that's why that works. So you're projecting away, you're taking the third vector, and what you're doing is you're applying this step right here. You're killing away, you're subtracting out the projection, but now it's a projection onto a plane instead of a line. And you can only project onto a plane if you already have an orthonormal basis for that plane. But this plane already has an orthonormal basis because you found it. It was V1 and V2. You found those already, and those are orthonormal, so you can do this. And you can keep doing this out. So that means V3 is just going to be this W3 divided by its norm. And this keeps going. Right? So if you want to find the nth vector, well, you're just going to find Wn and divide by its norm. And Wn itself is just going to be the nth basis vector in your list, and you're going to subtract out all the previous projections. So that's the formula that we're going to use. Again, this formula is somewhat complicated. It's easier to memorize if you understand the two main steps. The two main steps are project out all the other vectors and then divide by the norm of the result.